was looking at the commit logs referenced in this research stack, the one on the state of software development in 2026, and there is one number that just stops you cold. 75%.
The GitHub statistic.
Right. As of early 2026, 75% of all new code committed to GitHub is AI generated. That's a massive shift. I mean, we aren't talking about autocomplete anymore.
No, not at all.
We are talking about the vast majority of the internet's infrastructure being built by machines.
It really kills that old laying bricks metaphor for coding, doesn't it? We used to think of developers as these, masons placing one syntax brick at a time, making sure the wall was straight.
I know.
That 75% figure tells us the masonry work it's effectively a solved problem.
And the research suggests we've moved to a director model, which that makes so much sense. If you think about a film director, they aren't holding the boom mic, right? They aren't sewing the costumes or adjusting the lighting. They're watching the dailies.
Exactly. The human developer holds the vision. They know what the scene needs to convey, the emotion, the outcome. In this new world, the AI, your Copilot workspace, your Devin, they're your actors, your camera crew.
They execute the work.
They execute. But the director's job is arguably harder. You have to synthesize all of it.
Well, syntax is cheap. Architecture is expensive. That was the phrase from the report that really stuck with me. The AI gives you the syntax for free, a perfect Python loop in, a millisecond?
Right.
But if you don't know how to structure the story, the actual system architecture, you're just going to direct a really, really terrible movie.
And that's really the mission for this deep dive, isn't it? We need to figure out how we got from manual bricklaying to this. AI-augmented directing. What tools are actually doing the heavy lifting? And, are the humans still relevant?
To understand the now, I think we have to look at the first casualty of this whole revolution, the death of the forum.
Stack Overflow.
It's almost tragic, honestly. I built my entire career on Stack Overflow. If I had a bug in 2018, I'd search it, find a thread from 5 years before, and copy the answer.
We all did.
But the traffic data, it shows a 60% drop in active users. That is a ghost town trajectory.
But just think about the friction in that old experience. You had a problem, you went to a forum, you searched, you read like 5 different answers.
And tried to figure out which one actually applied to your specific version of the software.
Yes. Maybe the thread is about Python 2 and you're on Python 3. You try it. It fails. You go back. It was this whole investigative process.
It was slow, and you'd probably get yelled at by a moderator for asking a duplicate question.
Right. Now, developers aren't searching public forums. They're just asking their local large language models. And the key word there is local.
Because it's inside your code environment.
It already knows your context.
Yeah.
That's the critical difference. The AI knows you're using a specific library for data viz. It knows your variable names. It knows your goal is a dashboard, not a database.
You don't have to explain the whole problem to strangers on the internet.
Precisely. You just ask the AI, fix this function so it handles null values, and it just does it.
Yeah.
And it respects the existing style of your code base. The answer is instant, and it's bespoke.
So we've gone from searching to, contextual collaboration, and the tools are reflecting that. The research highlights that VS Code, which was king for a decade, is actually losing ground to AI-first editors, like Cursor.
Cursor is a great example of this shift. For so long, we just bolted AI plugins onto old text editors. But Cursor is different. It indexes your entire local code base using vector embeddings.
So it's not just looking at the one file you have open.
No, it understands the dependencies across all your files. If you change a function here, it knows how that impacts a module 3 folders down. It's offering real-time architectural suggestions before you even compile. It assumes you are collaborating with a machine.
And then there's the tool that takes it a step further. Devin. The research calls it an autonomous coding agent. This feels like a whole different category.
It is. Copilot or Cursor are assistants. They help you while you work. Devin is. Well, Devin is an employee. You can give it a Jira ticket, a bug report, and technically, you can walk away.
See, the idea that you can just go to sleep while software writes itself is the part that makes me a little nervous.
It should make you skeptical. But the capability is there. Devin analyzes the code base, it plans a fix, writes the code, spins up a sandbox environment to test it.
It tests its own code.
It does. And if it works, it generates a pull request for you to review in the morning.
It's an intern that runs on electricity and doesn't need coffee breaks. But does it actually finish the job? Or do you come back to a mess of spaghetti code you have to untangle?
That is the big question. In 2026, the answer is usually yes, it finishes the job. But the quality of that finish depends entirely on how well you define the task. It brings us right back to the director analogy. Vague instructions, vague results.
And it's not just back-end stuff either. The bridge between design and code seems to have finally crumbled. I saw the notes on Figma and Adobe XD.
This is a huge friction point that's just disappearing. Historically, a designer draws a beautiful interface, right? A complex dashboard.
And then a developer spends 2 weeks fighting with CSS to make it look like the picture.
And it never looked exactly like the pictures.
Never.
Now, these design tools use AI to export production-ready components, React, Vue, Flutter, whatever, directly from the canvas. You draw a button, and the tool gives you the code that makes it work, hover states, and accessibility tags included.
So if the AI is writing the syntax, fixing bugs overnight, and translating designs, what are the humans getting paid for? I'm looking at this list of new skills, and prompt engineering is right at the top.
I know, prompt engineering sounded like such a buzzword in 2023. A bit like growth hacking.
Yeah.
But in 2026, it is a sophisticated discipline. It's as important today as knowing memory management in C++ was 20 years ago. It's the art of communicating rigorously with a non-human intelligence.
The research breaks this down into some pretty dense concepts. Context injection, for instance. To me, that sounds like just pasting your README file into the chat window.
It used to be that simple, but professional context injection is about managing the LLM's limited attention span, its context window. You can't just say, make me a website.
Yeah.
You have to logically inject the specific business rules, the database schema, the security constraints, all before you ask for a single line of code.
You're essentially uploading the mental model of the project into the AI's short-term memory so it doesn't just make stuff up.
Exactly. So it doesn't hallucinate. You are declaring the environment. If you don't set the boundaries, the AI will guess. And AI guesses are often very confident, but very wrong.
That leads into chain of thought prompting. I've used this a bit. It feels like teaching a kid how to do long division.
That is an excellent comparison. If you just ask a model for a complex architectural decision, it might jump straight to a conclusion. But with chain of thought, you force it to explain its reasoning step by step. First, analyze the data load. Second, evaluate latency. Third, recommend a database.
By forcing it to show its work, you catch the errors in its logic before they become errors in your code.
Precisely. You aren't just asking for a result. You are designing the thought process.
And then there's constraint mapping, which this sounds like the safety belt in this speeding car.
It's the guardrails.
Right.
You explicitly tell the AI whatever you generate, it must adhere to OWASP security standards. It must not use deprecated libraries. It must handle PII data in this specific encrypted format. If you don't map those constraints, the AI takes the path of least resistance.
Which is almost always the least secure path.
Always.
So the focus has completely shifted to the business requirement is king and the syntax is just an implementation detail.
Yes. But this shift creates a massive, massive structural problem in the industry. The research calls it a junior developer crisis.
This is the part that worries me. If all the entry-level work, the bug fixing, the button moving is done by Devin, is the entry-level job dead?
It's the most controversial topic in the field right now. The job isn't dead, but the bar to get the job has just skyrocketed. Think about it economically. A junior developer costs, what, $80,000 a year? Takes a week to onboard? An AI agent costs $200 a month and starts instantly. The math is brutal.
So a junior developer in 2026 can't just be a coder. They have to be a senior developer from day one.
They need to understand system design, architecture skills we used to teach over 5 or 6 years. Now, we expect a 22-year-old to manage senior-level volume because they have these incredibly powerful tools.
But they don't have the wisdom. They haven't seen a server crash at 3 in the morning because of a bad database join.
And that is the trap. The sources call it the illusion of competence.
This concept really clicked for me. You get this clean, perfectly formatted Python script from the AI. It compiles, it runs, it looks like a pro wrote it.
But deep down, it might be hallucinating. It might rely on a library that doesn't actually exist, or introduce a subtle logic flaw, a race condition that only appears when 10,000 people hit the app at the exact same time.
So the junior developer sees this beautiful code and thinks, great, I'm done. They don't have the battle scars to look at it and say, wait a minute, this is going to deadlock the database.
Exactly. The human's job is now primarily verification, and verifying complex code is often harder than writing it from scratch. You have to be a code reviewer for a machine that writes faster than you can read.
Which brings us to security. The zero trust model isn't just for networks anymore, it's for your own code base.
You cannot trust the AI. You have to verify every single line. It's a paradox. The tools make us faster, but we have to be more paranoid. Interestingly, the research says we are now using AI to hack our own code.
Automated vulnerability scanning.
Yes, but way more aggressive. Before you deploy, you unleash an AI agent, an adversarial model, specifically designed to find SQL injections or cross-site scripting flaws in the code your other AI agent just wrote.
So it's AI policing AI?
It is. An endless loop of creation and destruction all happening in the background.
That is incredible. But let's zoom out. We have the tools, we have the risks. Why does this matter to someone who isn't a coder? Why should our listener care? And the answer seems to be speed.
Speed to market. This is the metric that changes business fundamentals. The research states that the time to build a minimum viable product, an MVP, has dropped from 3 months to 3 days for one developer.
3 days. That just changes the economics of innovation completely. If you have an idea, the cost to test it is almost zero.
It means you can afford to be wrong. You can try 10 ideas in a month. But it also changes the software itself. We're seeing a shift in architecture. Microservices breaking an app into tiny independent pieces used to be a huge headache.
You needed a whole team of DevOps engineers just to manage it.
Exactly. But now if you have AI agents monitoring traffic, they can suggest service boundaries, optimize the data flow in real time. Complex, scalable architectures are now accessible to one-person startups.
And this accessibility isn't just for Silicon Valley. There's a section in here about building Sudan with code that I found just really compelling.
This is the most profound example of the so what question.
The source talks about the tent of tech, about how these tools are a force multiplier for humanitarian initiatives. We aren't just talking about building apps, we're talking about building infrastructure in conflict zones.
When you lower the barrier to entry that much, you democratize solution building. Historically, if you wanted to build a logistics platform to distribute medicine, you needed a team of expensive engineers and servers. That just didn't exist in these regions.
But now, local developers who know the actual problems on the ground can use these AI tools to bridge that skills gap.
They're using offline LLMs to write code for low bandwidth networks. They're building SMS-based interfaces for healthcare. They are building world-class platforms without the world-class budget.
That's the key. It dramatically lowers the cost of innovation in places where innovation is life or death, not just profit.
It shifts the power dynamic. You don't have to wait for a big tech company to come and build a solution for you. You can build it yourself this afternoon.
However, we can't ignore the ethical considerations. The research touches on a few, specifically the data sets these models are trained on.
Right. There is the issue of bias.
Yeah.
We use an AI trained on older repositories that have, say, security flaws or biased logic. The new software will just perpetuate those same mistakes.
We're just automating our past mistakes.
Exactly. We have to be vigilant. And ownership is the other messy one. If I use an AI trained on open source code written by thousands of volunteers, and it generates a new app, who owns that?
Right. It's the remix culture problem, but for intellectual property. That's going to keep lawyers busy for a long, long time.
For the next decade, at least.
So looking forward, we're in 2026. What does the research say is next? The phrase natural language programming keeps coming up.
The expert consensus is that the code file itself, the .py or JS text file, might eventually become invisible.
Wait, invisible?
Think about it. We used to punch holes in cards, then we wrote assembly, then C++, Lark, then Python. Each step moved us further away from the machine and closer to human language. This is just the next logical step. The interface becomes purely conversational.
So you don't look at code anymore.
You discuss logic and outcomes with the system, and the system manages the executable binary in the background. The how, the syntax, the loops, the libraries, it all just disappears.
It becomes an implementation detail that humans don't need to see.
That's it. You focus entirely on the what.
That is, both liberating and terrifying, the ultimate abstraction layer.
As all great technological shifts are.
Wow. We have covered a massive amount of ground here, from that 75% AI code statistic to the death of Stack Overflow, from autonomous agents like Devin to the crisis-facing junior developers.
And the incredible potential for humanitarian impact.
So, if I had to distill this down to a main takeaway, the message seems to be adapt or die. But maybe less ominously, don't be afraid to change your role.
Absolutely. The best developers aren't refusing to use AI. They're the ones who treat it like a pair programmer. It's not a replacement. It's a force multiplier. Learn prompt engineering, understand architecture, and use these tools to amplify your own creativity.
And I want to leave you with this final thought. We talked about how the time to build an MVP has dropped to 3 days. The barrier to creation isn't knowing where to put a semicolon anymore. The barrier is just being able to describe your idea clearly. So if the only thing stopping you is your ability to articulate your vision, what problem have you been sitting on that you can finally solve yourself?
That is the question.
Thanks for diving deep with us. We'll see you next time.